Hey everyone, welcome to a new video on cryptography. Today I'm going to discuss about the Java implementation of Four Square Cipher. So let's start. Now before writing the code, let me explain the Four Square Cipher a little bit. So basically in Four Square Cipher we have three input string variables. The first one is the PT or plain text string variable, and also we have the key1 string variable as well as the key2 string variable. Also in Four Square Cipher we try to make use of four square matrices, each one of which is of the order of 5, and basically all these matrices will be basically merged into a bigger matrix which will be of the order of 10. Also it will be a square matrix, and now after that basically we try to divide the bigger matrix or the 10 by 10 matrix into four quadrants. Basically each of the quadrant will have a name: the top left or TL, the top right or TR, the bottom left as well as the bottom right. So basically each one of these will be a quadrant for the bigger matrix. And now coming on to the elements which each one of these matrices will actually have. So basically the top left matrix will be consisted of the elements of the English alphabet, where I and J are considered to be the same, and so will be the case for the bottom right matrix. And for the top right matrix we will have the elements or the characters which is basically present inside the key1 string variable, and for the bottom left matrix we basically have the characters which are actually present inside the key2 string variable. Now after the formation of the bigger matrix we basically have to pair the characters present inside the PT string variable. So the first and second character will form a pair, the third and fourth will form a pair, and so on. Basically if you have odd number of characters present in your PT string variable, then you can add one extra X at the end of your PT string variable. Now after all these naming conventions we basically have to encrypt our plain text. So for encryption we have to note down the row index of the character or the first character present in the pairs, and similarly for the second character for each of the pairs we have to note down the column index. And now after mapping the row and column value we have to find the character which lies at the junction point in terms of the bigger matrix which we had already formed. So this will basically be the first cipher element of our encrypted text, and the second one will be basically found by mapping the row value as well as the column value from the second element as well as the first element. So basically we have got our pair for the cipher element in the encrypted text. And now for each of the other remaining pairs of characters which we have inside the PT string variable, we have to do the same, and after that finally we will actually get our encrypted text. Now you can do the decryption in a similar process. Now if you want the full details as well as the full code for this cipher, then you can actually check the document which you can actually access by clicking on the link provided in the description section. So now let's start by writing the code for the main function. So basically now we are inside the public static void main function. So inside the main function we are taking the plain text as input from the user, and also we are taking the key1 and key2 string variables as input from the user as well, and later we are calling the encrypt function and storing the return value inside the encpt string variable, and doing the same for the decpt string variable as well, and later printing the encrypted text as well as the decrypted text, and later closing the scanner object for the main piece of program or inside the main function. Now we are going to declare the 5 global square matrices. The first one will be the bigger matrix, and the next 4 ones will be the small square quadrant matrices. After that we are going to write the encryption function. So we have written the encryption function. As you can see, basically this encryption function is taking 3 parameters as input. The first one is the PT string variable, and the next 2 ones are the key1 and key2 string variable. Now inside the encryption function, the first thing which we all are going to do is that first of all we are going to store the specific characters according to the rules as well as norms inside the 4 square quadrant matrices, that is the top right matrix. Also we have the bottom left matrix as well as the remaining 2, that is the top left as well as the bottom right square matrix. So the first for loop will basically store the specific characters inside the top right square matrix. The second for loop will store the necessary characters inside the bottom left square matrix, and the remaining two matrix, that is the top left as well as the bottom right square matrices, will actually have their characters stored by making use of the third for loop. And so after that, basically we are going to create one empty string variable of the name of seq or sequence, you can actually tell. So suppose after that, basically we are going to store each of the characters present in the upper half of the aggregate 2D matrix. Basically this is going to be the final matrix which we are going to achieve by combining all the matrices, that is the top left, top right, bottom left as well as bottom right. So basically this aggregate matrix, which will have 10 rows as well as 10 columns, can be divided into 4 quadrants. The upper 2 quadrants or the upper 2 parts will form the upper part, whereas the bottom 2 parts will form the bottom part. So the upper half will basically have some characters stored in the row wise format. So basically we are going to store each of the characters present in the upper half row wise inside the empty string variable, that is seq. And after storing all such characters row wise inside the empty string variable seq, we are going to go for the second for loop, that is this for loop. Basically this for loop will actually store each of the characters row wise inside the seq string variable. Basically we are going to concatenate each of the characters inside the seq string variable. Now after that, basically what we are going to do is that after that we are going to store each of the characters present inside the seq string variable row wise inside the aggregate matrix. Now after getting the aggregate matrix, that is the bigger matrix which has 10 rows as well as columns, we are going to get the row value as well as the column value. So remember we talked about the pairing of the characters present inside the string pt in the beginning of this video. So basically for each of such pairs we are going to store the row index for the first character present in the each of the pairs. So basically we are going to store the row index in the context of the aggregate matrix, and we are also going to store the column index inside the column integer in the context of the aggregate matrix for the second character which we have inside each of the pairs. And after getting the row as well as the column integer, we are going to map the row and column values with respect to the aggregate matrix, and basically we are going to arrive at one character. We are going to convert it to the string and concatenate it with the encpt string variable which was initially empty, we had declared in the beginning of this encrypt function. And after that we are actually going to do a very similar thing but in the opposite manner, that is we are going to store the row index in context of the aggregate matrix for the second element of each of the pairs, and we are going to store the column value for the first index for each of the pairs of characters which we have from the plain text string variable. So after getting the row value as well as the column value, again we are going to map it again with the row and column index of the aggregate matrix, and we are going to arrive at a character at the junction point of the row and column, and we are going to convert the character to the string and concatenate it with the encpt string variable. And for each of the iterations, basically you can see that this is the main for loop. So basically the main for loop will run as many number of times as the number of characters which we have inside the pt string variable. So that's how we are going to encrypt our encpt string variable, or we are going to encrypt the pt string variable. So after the end of the iteration, we are going to return the encrypt string variable. Now at last let us write the decryption function. Now in the decrypt function, as you can see, it is actually taking the same things as its input, but in place of pt string it is actually taking the input of string encpt, that is the encrypted text. And inside the decryption function, as you can see, everything is the same, but actually in place of the pt string variable we have taken the encrypted text, and actually everything else is the similar, but instead of manipulating or making use of the pt string, we are actually taking the encpt as our standard and doing the same things which we had actually done in the end of the encpt string variable here. So basically it is also going to store the row as well as column values for each of the pairs of characters which we have inside the encpt string variable. And so we are also going to map the row and column value for each of the first and second characters 2 times, and after that we are going to arrive at the first ciphertext as well as the second ciphertext for each of the characters which we have inside each of the pairs of the ENCPT string variable. So after that, basically we are also going to run the same iteration which we are actually done in the end of the ENCPT or encrypted function. So basically we are going to do the similar thing here inside of the decryption function as well. And after doing that, after basically the end of the iteration, we are going to return the decrypted text to the place where the function of decryption has actually been invoked in our main piece of code or main function. So that's it for the decryption function. Now let's run the code. Now as you can see, we've got the encrypted text as well as the decrypted text. So that's all from this video, guys. I hope you came to learn something new. If you liked my effort, then you can give it a thumbs up to my video and also subscribe to my channel for interesting updates. I'll be back with the other implementations of this cipher. Until then, keep exploring.